I welcome you all dear students. In this class, we will discuss some most important topics of electrostatics and some of the most important questions asked from electrostatics. Here it is. If you look at in what region of the space is the potential due to uniformly charged sphere the same as a point charge, as that of a point charge. In that region differs from that point, that of a point charge. In what region of a space is the potential due to uniformly charged sphere? This one is uniformly charged sphere. The same as the point charge. This uniformly point charge behaves like a single point charge. In what region it differs from that of a point charge? At what region it behaves like a single and what region it differs from a point charge? So here it is. Consider a charge sphere of radius r. Let there is a point P at a distance r. This point P is at a distance r from the center of the circle, where it is. So situated outside the sphere. Now the potential difference at point P due to the charge sphere is, here it is. This is basically V is equal to KQ divided by R square. This one is, if you calculate, put the values of electric intensity and every value, then you are getting potential difference due to charge Q at point R. So if the point P lies inside the sphere of the radius R, then at that time the potential will be V dash is equal to KQ divided by R. Distance of the surface is equal to the radius of the uh, circle. So this here we know that the potential at a point P due to point charge Q is given by, this is basically equal to KQ divided by R. This one KQ divided by R. Now the comparing equation 1 and 3, we see that the potential due to uniformly charged spheres where and that due to a point charge will be the same. If the P is situated outside the sphere, that is R is greater than R. Now the compare equation 2 and 3, because when R is greater than R, we will compare these two. When these are same, we will compare these two, 1 and 3. And if they are having a different distance, so here it will be. So comparing to equation 2 and 3, we see that the potential difference of the charge sphere that due to the point charge will differ if the point P is situated inside the charge, where R is smaller than R, where R is greater than R. So if you look at, you have calculated the potential difference at point R at radius of the circle, and you have compared the equation when this charge will be at a long distance and when it will be at a short distance. So let's go for another alternative. So this is another alternate answer for this question. The potential difference of a point charge Q at a distance r is given by this formula. The potential due to the charge sphere of Q at radius r and at a distance r is given by this one. So the comparing of these two equations shows that the both potentials are the same because the charge of the sphere behave like at the point charge. So the potential difference of the sphere will be different for a different point charge. If a point P is an electric potential is required to be calculated is situated outside the sphere, because potential difference is equal to V is equal to ED at E is 0 inside, while the sphere the potential V inside is also 0. So this is the reason whenever you are calculating potential, you are using the value of the distance from the charged particle. So that's why the more, if they are the same, then the situation will be different. If they are away from the charge, so the potential will be different. So this is the reason where you can calculate by considering the formula. By looking at the formula, it will be more easier for you to find out the answer. I thank you very much.